My name is Ulises Guerrero Valdez, and this is Evidence 2 of Matter and Energy 2. The first one says that we have two spheres that are positive charge with 0.1 meter of distance. So I use this formula that is constant per q square between distance square, and gave me 8.0889 newtons and positive charge reject. For the second one, they also gave us two spheres with 0.0180 kilos of mass and 0.5 meters of distance. So first we get the net mass, and then we made table of 3 where we multiply for 6.022 per 1023 and gave us 1.7057879 per 10 at 20, and multiplied by 29 and gave us 4.94678,506 per 10 at 21 electrons. That was the first answer. And for the B answer, we just used the formula of Q is equal to the square root of distance per force between constant, and gave us a resultant of 8.0742 per 10 at 14 electrons. For the third one, says a charge of 4 per 10 at -6 charge placed at point P within an electric field experience a force of -8 per 10 -4 newtons, and determine the intensity of the electric field. We use just the formula of electric field is equal to force between charge, and gave us -200 newtons per charge. In the fourth one, says an electron is traveling horizontally at a speed of 3.75 per 10 at 6 meters per second and enters in a uniform electric field. So basically, I just used the formula of electric field is equal to constant per charge between distance and substituted with the values that gave us here, and I got 1.8342 per 10 at 6, and the direction is to the right. And for the second answer, I use the formula of volt at square is equal to volt initial squared plus 2 AD over a to distance, and give me 2.511 per 10 at 14. For the fifth one, they just give us a theoretical problem, and the answer is the electric field is a force interacting between charges. To get the magnitude, we need to have charges of the particles and to know the distance between them. That is the answer of the fifth one. For the sixth one, they says that there's a sphere that has a diameter of 0.26 meters and exterior charge of 1030 newtons per charge. We get the charge that is 1.6 per 10 at -9. We just substitute in the formula the constant, the charge, and the distance that is already here, and gave me 1438.03879 newtons per charge. In the second paper, says that there's two plates, one with positive charge and the other with negative, and there's a distance of 0.05 meters, and the negative one has 5 per 10 at 6. So we just want to get the work. So the formula is work is equal to charge initial per ER of A plus QF of ER of B. We substitute and gave us 0.0125 joules. And for the eighth and final one, they just give us a point, and we get the charge. We need to get the electric field with the same equations of the last, and to get the potential energy, we just multiply the charge per the electric field per the distance, and gave us 11.5043 decimal joules. To get the voltage, we use the formula of potential energy between charge, and gave us 1,438,038.79 volts. The electric field, we use multiply the constant per the charge between the distance of the second charge that gave us, and gave us 10,785.29,093 newtons per charge. That is the electric field of the second charge. And the potential energy of the second charge is 1.61779 per 10 joules. And that's it.